Today, we're exploring a crucial technology in the fight against climate change: carbon capture. What is it, and how does it work? Let's break down the basics. Carbon capture technology refers to a range of processes designed to capture carbon dioxide, CO2, emissions, preventing them from entering the atmosphere or removing CO2 that's already there. The goal is to reduce the concentration of this major greenhouse gas. Often, you'll hear the acronym CCUS, which stands for Carbon Capture Utilization and Storage. There are two main approaches to capturing CO2. First, point source capture. This involves capturing CO2 right where it's produced in large quantities. Think industrial facilities like power plants, cement factories, or steel mills. The CO2 is separated from other gases in the facility's emissions before they are released. Second, direct air capture, or DAC. Unlike point source, DAC technologies pull CO2 directly out of the ambient air around us. This is much harder because CO2 is far less concentrated in the general atmosphere than in industrial exhaust, requiring more energy. So, what happens after the CO2 is captured? That's where the U and S in CCUS come in. Utilization means using the captured CO2 as a building block for other products. Examples include making fuels, chemicals, building materials like concrete, or even carbonating beverages. Storage, also known as sequestration, involves permanently storing the captured CO2 to prevent it from re-entering the atmosphere. The most common method is injecting the compressed CO2 deep underground into suitable geological formations, like depleted oil and gas reservoirs or deep saline aquifers, where it's trapped. While promising, carbon capture faces challenges. These include the high cost of capture processes, the significant energy required to operate the systems, especially DAC, ensuring the long-term permanence and safety of storage, and scaling the technology globally to make a meaningful impact. It's important to see carbon capture not as a silver bullet, but as one vital tool within a larger strategy for decarbonization, alongside renewable energy, energy efficiency, and reducing emissions at the source. That's a quick overview of carbon capture technology, a complex field but essential to understand as we tackle climate change. Thanks for listening.